So the first question is two bodies of equal masses are placed at height h and 2h. Find the ratio of their gravitational potential energy. So what is the formula of gravitational potential energy? That is mgh. mgh. So here you can see that the mass is equal and the g is also will be equal for the two masses, that means for the two bodies. Only the difference is in height. First body is placed at h height and the second body is placed at 2h, that means the double height. So here the ratio will depend only on h, as because m and g are equal for two of them. So to find the ratio, we only find the ratio of their height, and that is h is to 2h. That means h can cancel and the ratio is 1 is to 2. So this is very basic questions. So we are moving to the second question. So the second question is also a very basic question. It is asking for the potential energy of a body which is of mass 1 kg. Okay, fine. So mass is 1 kg. So kg, that means it is given in SI unit. Height is 5 meter. So height is also given in SI unit, no problem with that. And g is given over here, that is 10 meter per second square. So all the three parameters are in SI unit. So we can directly calculate the potential energy, that is mgh. So 1 into 5 into 10, that is going to be 50. As it is about energy, then the unit will be joule. Second one is also very basic question. So we are moving to the third question. Third question, a box of weight 150 kgf, that means mass is given, mass is given, that is 150 kgf. Okay, has the gravitational potential energy stored in it equal to 14700. That means here they give you the value of mgh, that means the potential energy it is given, that is 14700 joule. Find the height of the box, that means the box has been placed at a height and you need to find out that height. So this is not given, where g is also given, that is 9.8 over here. So check whether all the parameters are in SI unit or not. Okay, Newton per kg, that means everything is given in SI unit, so we can directly calculate it. So we know that potential energy is equals to mgh. So it is 14700. M is given over here, that is 150. G is also given, that is 9.8, and H is not given. So we can easily find out the value of H if we just divide 14700 by 150 into 9.8 is equal to H. So it is going to be, I'm going to erase this portion, and the H is going to be 14700, and 150 into 9.8, if you just calculate it, it will be 147.0, and divide that, we give you 10. So they are asking for the H, so H is going to be 10 meter. So the answer is 10 meter. We are moving to the fourth numerical. So the fourth question, a body of mass 5 kg falls from a height of 10 meter to 4 meter. That means a body was previously placed at 10 meter and then it dropped up to 4 meter. That means there is a change in the position, or you can say in the height, that is for 6 meter. And they're asking that what is the loss in potential energy. As the body is decreasing in height, there will definitely be a loss, and the loss is actually depend on the decrease in height. So how we are going to calculate it? There is two way actually. You can calculate the potential energy over here, and then you can calculate the potential energy over here, and then you can subtract the value over here from the value on the 10 meter. But here we are going to do it directly. Listen, the mass is 5 kg, so we are going to write it 5. Here it is, and g is given, that is 10, so directly we write 10. It is given in SI unit. The mass is also given in SI unit, and actually there is the fall of 6 meters, so we are going to write 6 meter, because what you know that loss in potential energy is actually fall in height. We know, we have studied it in earlier video. If you have not, then go for the videos in the playlist. We proved it over there, that loss in potential energy means fall in the height. So here the fall in the height is 6 meter, so we are just going to calculate it directly, and that is going to be 5 into 1050 into 6, that means 300 joule. So there will be a loss of 300 joule because the body is falling from 10 meter to the 4 meter. Then the second part of the question is asking the total energy possessed by the body at any instant. Also we have studied the conservation law, and there we have seen that if a body is falling from a height to the earth, the potential energy and the kinetic energy, there will be interchange in the potential energy and kinetic energy. Potential energy will be converted into the kinetic energy, but at each and every point the total amount of energy will be constant. There will be no change in the total amount of energy. It is exactly equal to the energy it was having when it was over here, right? So we just have to calculate the potential energy in the body when the body was placed at 10 meter height. So the potential energy of the body at 10 meter is 5 into, again g means 10, and it is at 10 meter, so we are going to write 10 over here, and that is exactly 500 joule. So the question is asking for the which body to height. Then they're asking for the height, so height is not given over here. Okay, fine. Mass is given, that is 0.5 kg, or you can write 1 by 2 kg, and there is g, that is 10 meter per second square. And read the question. Calculate the height through which a body of mass 0.5 kg should be lifted if the energy spent, so this line is important. So energy spent is 1 joule. 1.0 joule means 1 joule. So that means whatever is the energy we are spending to do the work is actually going to store in the body we lift. So here the energy is given, so we will write 1, and mass is given, that is half m, g is 10, and h is not given. H is going to be 2 5s are 10. That means h is going to be 1 by 5, and that is point 2 meter. This is also a basic question. Read the question carefully. The mass is given, that is 25 kgf. Okay, g is also given, that is 10 newton per kg. Okay, fine. And h, now read the question again. The boy climbs up from the first floor at height 3 meter above the ground to the third floor at height 9 meter above the ground. That means the displacement of the body, that means the height is actually from 3 meter to 9 meter. That means it displaces about just 9 minus 3, 6 meter. From 3 meter it goes to the 9 meter. Actually it has been raised, the boy actually climbs only for 6 meter. So the potential energy is going to be mgh, you know, and m is 25 over here, and g is 10, it is given, and height is 6, so 1500 joule. So question number 7. A vessel containing 50 kg of water, that means the mass is 50 kg. Okay, placed at a height 15 meter. So height is 15 meter above the ground. Okay, fine. Assuming the gravitational potential energy at the ground to be 0. So this information is an extra information, you can just neglect it. We all know that in the ground, that means this ground, and here is the body which is at 15 meter. We all know that here the potential energy will be 0. They are actually saying the same thing, so you can neglect this line. What will be the gravitational potential energy of water in the vessel? If g is given 10 meter per second. Check, all the parameters are given in SI unit. Okay, fine. Then they are asking for the potential energy. What is the potential energy? So potential energy is going to be mgh, mass 50 kg, g is 10 and h is 15. So 5 15 is 75 and 2 zeros, that is 7500 joule. Question number 8. A man of mass 50 kg climbs off, that means mass is given, write it down, that is 50 kg, climbs up a ladder of height 10 meter. Height is 10 meter. Calculate the work done. G is given over here. Okay, they are asking for the work done. Okay, fine. So G is 9.8 meter per second square. Okay, so work done. So what we need to do? Okay, we have a concept, that means work done is actually the energy we spend to do our work. Work done and energy are the same thing, I have told you in the earlier videos. So here we are just going to calculate the energy, and that is also potential energy. So again we are using mgh, and that is 50 and 10, and this is sorry, I should write proper thing in proper places. G is 10 and the again I did it wrong. G is 9.8 and H is 10. So calculate it, it is going to be 4900 and 10 cancelled. Okay, 4900 joule. Okay, fine, this is the work done. And go for the second part. The increase in his potential is 900 joule. We don't have to calculate, because whatever is the work done is actually same as the energy that the man actually grows in inside him. Now this question is going to be a little bit tricky. So read the question first. A block A, here is the block, whose weight is 100 Newton. That means the weight of the body is 100 Newton, is pulled up a slope of length 5 meter. That means the length of this thing is 5 meter. It is also given in the diagram by the means of a constant force of 100 Newton. Obviously, if the weight of the body is 100 Newton, you have to apply the force, and they have also give the direction of the force, and that is equal to 100 Newton. Okay, no problem. Now the question is, what is the work done by the force F in moving the block A 5 meter along the slope? That means they are asking for the work done by the force. So here the direction of the force is very important, as we know that the work done is F into S into cos theta. Here cos theta, okay, we should write it cos theta. So we can see here the movement of the body, the direction of the movement of the body and the direction of the force are in the same straight line. So we can neglect this value, the value of cos theta. So we can just multiply the value of S and the value of F. So what is F? F is 100 Newton and S is 5 meter. So it is going to be 500 joule. The easy one. B. What is the increase in the potential energy of the block A? So once the block has been placed over here, now the block is actually at a height of 3 meter. So potential energy is actually depend on this height, this 3 meter. So what is the formula of potential energy? That is M, G and H. The mass is not given here. They gave us the weight in Newton. That means they gave us the value of M and G. Mind it, the value of M and G is 100. We should not multiply 9.8 or 10 as G. We often do a mistake. We often think that this 100 Newton is mass, and we then multiply the G with 100, and that is totally wrong. They gave you the weight in Newton. That means they already multiplied the value of G with the mass of the body. They have given here the M and G all together, and that is 100 Newton. So that's why the unit over here is Newton. So we should multiply 100, and then the height is 3 meter. So here 3, that is 300 joule. So now the body is having 300 joule when the body is over here. Now go to the third question. Account for the difference in the work done by the force and in the increase in the potential energy of the block. So what we know, that this work done and the energy should be equal. As I have said you earlier, that the work done is actually the same, the energy is in the body. But here we can see that work done is 500 joule, but the body is having 300 joule. So there is a deficit of 200 joule. Now where that 200 joule gone? So actually we are lifting this body through a slope, and the slope is not frictionless. So due to the friction, actually 200 joule of energy is, we are actually losing the energy. So energy, we will write energy loss due to the friction, due to the friction in the slope is 200 joule. Clear? Question number 10. So finally we got a question which is asking for the kinetic energy. So here the mass of the body is given, that is 1 kg, and uniform velocity. So velocity is given here, that is 10 meter per second. Check whether they all are in SI unit or not. They all are in SI system. Okay, fine. Then kinetic energy. Okay, fine. So what is the formula for kinetic energy? That is half mv square. So half m is 1 kg over here, and v is 10 meter per second. So we should write v square, that means 10 into 10. We write 10 two times, or you can write in square also. So 2 5 is 10, and that is 50 joule. Very easy calculation. Is the amount of kinetic energy in the moving body. Question number 11. So now this is going to be a very conceptual question. So watch carefully. If the speed of a car is halved, how does its kinetic energy change? Okay, fine. That means the previous speed, whatever it is, v1 is equal to v, suppose. That means this one is the initial, and then the speed is halved. That means finally the v2 is v by 2. Why? Whatever is the speed in initial is going to be halved in final. Okay, then they are asking that what will be the change in the kinetic energy. So the initial kinetic energy is to the final kinetic energy is going to be like something like half m v1 square is to half m v2 square. Okay, put them in bracket for better understanding. Is to, this is to, listen, this half and this half is going to be cancelled. This is also going to be cancelled, but here v1 means what? V. So we will write v square. So this is the ratio of k initial and the k final. That means the initial kinetic energy and the final kinetic energy, and this is going to be v by 2. The final velocity is v by 2. It is being halved square. So finally it is going to be v square is to v square by 4. V square by 4. 2 was here. So 2 square is 4. So it is going to be cancelled, and it is exactly 1 is to 1 by 4. That means whatever is the kinetic energy in initial is going to be 1/4 in the final. That means this is a very useful concept. You can use it in everywhere. I can say, okay, let me clear the whiteboard. Okay, if the speed is being halved, that means kinetic energy will be 1/4, as the formula for kinetic energy is half m v square. So for this v square, half is actually going to be in squared value. So if they ask you that the velocity changes to 1/3, then what will be the change in the kinetic energy? So that is going to be 1 by 9 part. If the v is 1 by 6th, then the kinetic energy is going to be 1 by 36, like this. So you got my point? I hope so. So we are moving to the next question. So now this question may seems to you that it is same as the previous, but there they asked for the ratio in the kinetic energy, but here they are asking for the decrease in the kinetic energy. So you should be very careful about this kind of questions. They just apply the word and the meaning is totally changed for the question. So here we are going to calculate it differently. So the uh, initial kinetic energy is half mv square, and then it has been halved, then it will be half m v square by 4. How? V by 2, that means if the speed has been halved, then it will be v by 2, and the square means v square by 4. So we just directly applied it over here. And why we put this negative minus sign? Because they are asking for the decrease. So we need to calculate the difference between the final and the initial. So we are doing the subtraction. So half m v square minus, we can write half m v square into 1 by 4. We just depart this 1 by 4 from the actual formula. So we can write, here is half mv square and here is also half mv square. So we can write 1 minus 1 by 4. Can we write? So it is going to be 3 by 4. So actually in previous sum we have seen that if the velocity is been halved, then there is the ratio, that is 1 is to 1 by 4th. That means the kinetic energy is actually 1/4 of the initial. Then what is the change? Very easy, 1 minus 1 by 4th, that is 3 by 4th. So it decreased 3 part. Now the kinetic energy in the body is only 1 part of the previous. This is the concept. Two bodies of equal mass are moving with uniform velocity v and 2v. Two different velocities. Okay, fine. Find the ratio of their kinetic energy. So half m mass is equal for the two bodies. So half m, the first body is having the velocity, that is v, so v square is to, we need to find out the ratio. Half, the mass is same, so again m, and here the velocity is 2v, so we will write 2v square. Half half cancelled, m f cancelled, then here it is v square is 2, here it is 2 2s are 4 and v square. So v square also cancelled, and now it is 1 is to 4. So the ratio is 1 is to 4 again. Two car, one is running at 50 km per hour, while the another car is running at 45 km per hour, and you have to find out the kinetic energy in the two. Okay, fine. So for the first car, half m, mass is not given, so we are going to just write m, and speed is given here, that is 15 km per hour. You may ask me that why don't we convert it in meter per second, because we always make it meter per second to calculate in SI system. So as here we are actually calculating the ratio, there is no need to convert it. Actually they will be balanced in two sides, and they will give us the ratio whatever it is in kilometer per hour or meter per second. So here we are not going to convert them in meter per second, we are just calculating directly. So half m, and it is 45 meter square. So half got cancelled, m got cancelled, and here it is 15 square means 225, and the 45 is going to be 900, and if we just reduce it by 5, then it is 45 is to 180, then reduced it by 9 5s are 45 and 920, so finally it is going to be 1 is to 4. So again the ratio between the first and the second curve is 1 is to 4. A ball of mass 0.5 kg, that means mass is given, that is 0.5 kg, and that is equal to 1 by 2 or half kg, slows down from a speed of 5 meter per second square, 5 meter per second, and to the 3 meter per second. So here you can solve it in this way, that you first go for the initial kinetic energy and then go for the final kinetic energy by this 3 meter per second, and then you can subtract the final kinetic energy from the initial kinetic energy, or you can do it directly. How? I'm just showing you. So mass is given here, mass is not going to be change, so the change in the kinetic, they are asking for the change in the kinetic energy. So you can do one thing, you just write half and then the mass, that is half kg. We are putting in the formula k is equal to half mv square. Okay, so we are putting all the values in this formula. So half is over here, mass is also half kg, so we write half over here, and there is the change of velocity, that is 5 meter per second to 3 meter per second. So 3 meter per second. So here the formula is v square, so be very careful. So we will write the 5 in square, because v is in square minus 3 square. So don't write it like this, 5 minus 3 square, it is wrong. We should write 5 square minus 3 square. So it is 1 by 4 into this one. As you can see, we can apply one thing, a square minus b square is a plus b into a minus b. Just apply these things. So 5 plus 3, that is 8 into 3, 5 minus 3, that is 2. So that is 1 by 4 into 8 into 16, so 4 4s are 16, so actually 4 joule. So there will be a change of 4 joule in the kinetic energy. Okay, a cannonball of mass 500 gram. So mass is given, that is 500 gram, that means it is in CGS, so we should make it in SI system, as the rest of all is given in SI system. So 500 gram means we can write 1 by 2 kg, half kg. Then it is fired at a speed of 15, that means v is given 15 meter per second. Okay, so what is the kinetic energy? Kinetic energy, that is equal to half m is over here, that is 1 by 2 into v square, that means 15 square, so it is going to be 1 by 4 into 225, and 225 by 4, that is going to be 56.25 joule. Okay, now in the second part they are asking for the momentum. I hope you all can recall the formula of momentum. So momentum is actually denoted by p, and the formula is mass into velocity. Momentum is the product of mass and the velocity. So mass is 1 by 2 and the velocity is 15, and that is going to be 7.5. And what is the unit for the momentum? Mass into velocity. That means mass is in kg and the velocity is in meter per second, so the unit will be kg meter per second. So we will write kg meter per second. So a body of mass 10 kg, that means mass is given, that is 10 kg. The velocity is given, that is 20 meter per second. If the mass of the body is doubled, so mass is going to be doubled and the velocity is going to be halved, then you have to find out the initial kinetic energy and the final kinetic energy. Okay, so we are first going for the so first we are going for the initial value, initial kinetic energy. So that is half mv square. So half m is 10 and v square means 20 into 20, it is 10, so that is 2000 joule. And for the final half, mass is going to be doubled. So here the mass is 20, mass is going to be doubled over here, so that is 20, and the velocity is going to be halved, that means 20 is going to be 10, then 10 into 10 because v square, okay, half into, okay, sorry, then 2 tens are 20 and it is 1000 joule. So initially it was 2000 joule and then mass got doubled and the velocity got halved, then the final kinetic energy is 1000 joule. A truck weighing 1000 kgf changed its speed from 36 km per hour to 72 km per hour in 2 minutes. So mass is given here, so we write down the mass first, that is 1000 kgf. Now what the information is? The information is the truck is increasing its speed from 36 km per hour to 72 km per hour. So what we're going to do, we are just going to convert the kilometer per hour to the meter per second. So 36 km per hour is v1, it was the initial velocity. So in meter per second it will be 10 meter per second, and I hope you know how to convert the kilometer per hour to meter per second. And the second velocity is 72 kilometer per hour, and in meter per second it will be 20 meter per second. So they are asking for the work done by the engine. Work done for what? As the engine increase its speed from 36 km per hour to 72 km per hour, or we can say that from 10 meter per second to 20 meter per second, that means it just doubled its speed. So to increase the speed, engine need to do a work, and we just have to calculate the work done. So what concept we are going to use here is work done means what? Work done means the change in the kinetic energy. So you can do it by finding the kinetic energy when the velocity was 10 meter per second, and then finding the kinetic energy when the velocity got doubled and it is 20 meter per second, and you can subtract the initial kinetic energy and the final kinetic energy, or you can do it directly I will prefer do it directly. So work done is exactly equal to the change in the kinetic energy, and that is half m means 1000, and then v square. Here the final velocity is 20, and that is square, and then there is the change, and that is 10 square. So it is going to be half and then 1000. Then apply a square minus b square formula. You know what is the formula? That a square minus b square is equal to a plus b into a minus b. We all know. So the same thing we are going to apply over here. This is a and this is b. So a plus b, that means 20 plus 10, and 20 plus 10 is 30, and 20 minus 10 is 10. So it is 500. So 5 into 3 15, then 1 2 3 4 joule. Or you can write 1.5 into 10 to the power 5 joule. So what is the amount of work done? The amount of work done is 1.5 into 10 to the power 5 joule. Now they are asking for the power. So they gave us the time 2 minutes. So in 2 minutes there is the change in the velocity or speed. So what is power? So we know what is the formula of power. First I should clear this side. Okay, so power is work done by time. We already have that work done. The amount of work done is 1.5 into 10 to the power 5 joule. I am going to take this one for the easy calculation. 1 5 1 2 3 4, and then the time is in minute. You can see 2 minute. So we need to convert it in second. Because of what? The unit of power is joule per second, so we cannot divide it by the minute. So we need to convert it in second, and that is 120 second. So divided by the time. Okay, so it is going to be 12. 1250 joule, or you can write in one significant figure 1.25 into 10 to the power 3 joule. A body of mass 60 kg has the momentum of 3000 kg meter per second. Okay, so mass is given, that is 60 kg, and here they gave us the momentum, that is 3000 kg meter per second. Okay, fine. So we have to calculate the kinetic energy, and for the kinetic energy we need mass and the velocity. So here the velocity is not given, but they gave us the momentum. So from this momentum we can find out the value of velocity. What we know, that is P equal to m into v. So we are going to put the value of momentum, that is 3000 is equal to m is 60 and v is unknown. So here 3000 by 3000 by 60 is equal to v, and that is going to be exactly v is equal to 5. Okay, 50 meter per second. This is the velocity. So now we can easily calculate the kinetic energy, because we are having mass and velocity both. So half into mass is 60 and the velocity is 50, so that is 30. And now it is, oh, I'm very sorry, half mv square, so 50 into 50, so it is going to be 3 5s are 15, 15 into 5, that is 75, and 30, that is 7.5 into 10 to the power 4 joule is the answer for the first part. This is the kinetic energy. And they are asking for the speed of the body. We already have found it, that is v is equal to 50 meter per second. Here it is. How much work is needed to be done on a ball of mass 50 gram? That means mass is given, that is 50 gram, or we can write 50 by 1000, 10 got cancelled, and it is 5 by 100 kg. Always keep the value in fractional value. It will make your calculation easy. Then 50 gram to give it a momentum, so momentum is given over here, that is 5 kg meter per second. Now this is kind of a tricky question, okay, and they are asking for the work done. So this thing is clear, as they are asking for the work done, we need to find out the energy, and obviously as the ball is moving, so we need to find out the kinetic energy, that is for sure. So to calculate the kinetic energy, we need two things. One is mass and another one is v. So v is not given here, but they gave us the momentum. So what we can do, by the formula of momentum, we are going to find out the value of velocity or speed, whatever you can say. So p is equal to m into v. So p is 5 and m is 5 by 100, and the v is not given, so we are going to calculate the v. Then v is 5 into 100 by 5, so 5 got cancelled, and it is 100 meter per second, obviously. So now we have two values, that is m and another one is v, so we can easily find out the kinetic energy, and furthermore, which is going to be exactly equal to the work done. So by the formula of kinetic energy, half m means 5 by 100, and then v square, that means 100 into 100, so 100 got cancelled, then 250, and 5 into 50, that means it is 250 joule. So how much work is needed to be done? That is 250 joule. How much energy is gained by a box of mass 20 kg when a man carrying the box and wait for 5 minutes for a bus? Okay, so for the part of A, the man is actually holding the box at a certain height and he is not moving, so there is no displacement, means there is no work done for that particular 5 minutes. For this particular 5 minutes there is no work done, because there is no displacement. So you can write no displacement, no displacement, that means no work done for that particular 5 minutes. Then part B, runs carrying the box with a speed of 3 meter per second to catch the bus. Okay, fine. So now the man is actually moving. So here we can write it like ke is equal to half m v square. So half m is 20 kg over here, and v means 3 meter per second, so 3 is 2 times because v is squared. Then 10, so 3 3 is 9, it is exactly 90 joule. Now for the C part, he raised the box by 0.5 meter in order to place it inside the bus. So where the box is actually raising at a height, that means there should be a kind of potential energy. Now the man is not moving, he is just raising the box at a height, so there will be a potential energy, and the formula of potential energy is m, g and h. So g is given over here, that is 10. So mass is 20 kg, again 20, and 10 is the value of g, and h means the height it has been placed, so 0.5 meter. So we can write 1 by 2 meter. So 2 tens are 20, and that is going to be 100. So 100 joule is the amount of potential energy after the man raised it at a height of 0.5 meter. A bullet of mass 50 gram is moving with a velocity of 500 meter per second. It penetrates 10 centimeter into a small target and comes to rest. Calculate the kinetic energy possessed by the bullet and the average retarding force offered by the target. Okay, fine. This question is kind of standard question. So we are going to write down the given value for first. M is given, that is 50 gram. So 50 gram, so we need to convert it in SI unit. So that is 50 by 1000, and finally 10 got cancelled, it is 5 by 100. I always prefer to keep the value in fractional form, and V is given here, that is 500 meter per second by 100, and V square is 500 into 500, it is going to be cancelled by 5 and 250. 5 5s are 25, and 25 into 25, that is 625. 625 and 10 is here, so 6250 joule is the kinetic energy. Now we are coming to the concept. So what happened when the bullet was moving? When the bullet was moving with a speed of 500 meter per second, then it was having that kinetic energy. When it was moving, there was the kinetic energy. So when it hits the target and comes to the rest inside this target, it got 10 centimeter, it penetrated 10 centimeter in the target, and it is in rest now. So what will happen instantly? The time instant it just hit this target and penetrate for 10 centimeter, and it stops over there. The whole kinetic energy is actually going to convert in the potential energy. So if I just say in the bullet, still now the energy is nothing but 6250 joule. How? There it was kinetic energy. Now the bullet has been stopped in the target. It is now still. So the whole kinetic energy is changed in the potential energy. That means still the bullet is having 6250 joule, but the form of energy is now potential, as the bullet is not moving. It is still. So now they are asking that what will be the retarding force. That means why the bullet stop, as because the target is actually offered a retarding force. That force makes the bullet stop. So how do we find out the force? So here we are going to use a concept. What? Now what we know, that whatever is the energy, whatever is the change in the energy, that is actually same as the work done. So here the total kinetic energy changes into potential energy, and that is 6250 joule. So can we just say that work done over here is exactly equal to the energy, and that is 6250 joule. So what we know, that W equal to F into S. Now to stop the bullet, the energy spent is 6250 joule. That means the work done is also 6250 joule. Okay, we write the value of work done, and then we don't know the force, but we know the displacement, that is 10 centimeter. It penetrates 10 centimeter inside the target. That means we write 10 over here. It is given in centimeter, we need to convert it in meter. So by 100, then 10, 100 will be over there, so it is going to be 6 to 5, then 20 to Newton. So what is the amount of retarding force offered by the block, that means the target, that is 62500 Newton, to stop the bullet. The spring is kept compressed by a small trolley of mass 0.5 kg lying on a smooth horizontal surface as shown. When the trolley is released, it is found to move at a speed of v, that is 2 meter per second. What potential energy did the spring compressed when possess when compressed? Okay, fine. That means this trolley is actually this trolley is actually compressing this spring, and now the spring is having a potential energy, and the type of potential energy is elastic potential energy. And I'm just pressing the trolley, so that's why the spring is compressed, and now whatever is the potential energy is going to convert in the kinetic energy at the time instant I am just releasing the trolley. Okay, and for that potential energy, the kinetic energy will imposed over here, and the trolley will move, and the velocity of the trolley is 2 meter per second. So now what they are asking for, they are asking for this potential energy. So what can we do? We can just find out the kinetic energy of this trolley. Why? If we somehow find out the kinetic energy of the trolley, then it will exactly be equal to the potential energy in the spring, as because the transformation of the energy from potential to the kinetic, the trolley is having the velocity. So we can easily calculate the kinetic energy of the trolley, as the mass and the velocity of the trolley is given over here. So the mass of the trolley is 0.5 kg, or we can write that is 1 by 2 kg. Okay, and velocity is given, that is 2 meter per second. No problem, it is given in SI system. So what is the kinetic energy we are going to calculate? That is half mv square. That means half into m means also half, and then v square is 2 into 2. So 2 got cancelled, 2 got cancelled. It is exactly 1 joule. So 1 joule is the kinetic energy in the trolley. And where from the trolley got that kinetic energy? From the potential energy, elastic potential energy of the spring. So what is the amount of elastic potential energy in the spring? That is also 1 joule. So the answer is 1 joule.